There we go. No pressure or anything.
Yeah, no, I don't feel anything.
She's gonna be on YouTube forever.
So I did my class of rock.
Mm-hmm.
Do you want me to just go through all of them, like the instances?
Yeah, let's.
Cool. My instances are fluorite, citrine, and quartz.
Yeah.
Then my attributes were weight, shape, and color.
Mm-hmm.
And then the behaviors I have polish, throw rock, break.
Yeah, those are things that rocks do. Cool. Excellent. Thank you very much. All right. So today we're going to be talking about like classes, objects, methods, how these kind of link together. We kind of saw how we were putting these together a little bit yesterday. But today we're kind of going to get into like kind of like the why and talk about OP a little bit. So in programming, class, let's use capital C, class, is something that models state and behavior. Right, that's kind of how we want you to start thinking as we had you do that kind of that exercise. The difference between the two is that state is what something is. Behavior is what something does. Right. And so when we're talking that example that we used for the refrigerator, the state of the refrigerator would be attributes such as a brand, a color, a temperature. For example, my refrigerator, it's a Whirlpool. It is silver, and its temperature is 40 degrees. These are bits of information that are about that my particular refrigerator. Right? And so an object is a concrete representation of a class. And so we want to talk about the difference between a class and an object. When we think about a class, like I want to, like if we're continuing to talk about the refrigerators, or the idea of a refrigerator, the template refrigerator is essentially a box that keeps things cold, right? And so that's all refrigerators. Particular objects are specific instances of refrigerators. For example, my refrigerator in my kitchen over there is an instance of a refrigerator. Your refrigerators, wherever they are in your home, are instances of a refrigerator. Right, so like my refrigerator is what I say, Whirlpool, silver, 40 degrees. Your refrigerator might be Frigidaire. Is that a brand? Sure, Frigidaire refrigerator. It could be white, and it could be set at 37 degrees, right? These are two different things. Another kind of example we have is a car. You could drive a Ford Focus that's blue, and that's still a car. Someone else could drive, a Toyota Prius that's green, right? These are two different instances of a car. And we kind of get even a little more granular. What if we have two Ford Focuses, whatever, that are both blue, right? And they are like essentially identical, but they are still two separate things. They both came from like this idea of this blueprint, and the class is a blueprint. Like at the factory, the car factory, they make cars, they paint the same color, but each individual one is separate. And I think in the lesson plan, there's one statement, the blue, like that uses the idea of a house, right? Think of a class as a blueprint for a house, and instance is an actual house. The blueprint is just an idea of the house should be built, and the house is the realization of the blueprint. I think that's a really well written and like kind of philosophical kind of way to think about something. about an object being the realization of an idea. And so when we're working with classes, we first got to talk about how we define a class. And in Ruby, the standard syntax of defining a class looks like this. Class, name of class, end. I want to note that for multi-word classes, the capital letter of the first letter of each word is capitalized. Like that is a convention we will stick to. And that is like one of those things that is a must. So an example for this, like if we were going to make a dog class, it would look like this. Class, dog. We have the class keyword, what we're going to call the class after that, and we throw on an end at the end. Like I say, whenever I have a thing that needs an end, I automatically type that end in because I will forget later. I just find it to be a good habit, just get that end right there and then go up and go in the middle, whatever you want to type. This habit of capitalizing each first letter of each word is called upper camel case. Cool. Any questions so far about this syntax before we kind of go on? Cool, cool. All right. So what we're going to do is that I am going to make some files here. Ahead of time, I've made a unicorn.rb because I'm going to make a unicorn class, and I'm going to do that here. Is this text big enough for everyone? Would anyone like this larger? It is okay to ask for larger. Well, everyone seems to be okay. Cool. And I want to note that the class name, unicorn, should match the file name, unicorn. However, the convention is that the file name is lowercase lowercase whatever. And that's going to be like the pattern that we use. The reason why is that there's this idea called the principle of least surprise. We write things in this manner because it is the least surprising. For example, if you were to go on a code base you're new to, and you're looking for a pizza class, you're going to expect that that class is going to be found in pizza.rb, right? There's no, it's like, yeah, pizza class, pizza RB, got it. There's no like extra kind of intellectual or mental jump you got to make. However, if I were to put the pizza class in something.rb, like why would you'd have to know that it was in there? Someone would have to tell you, and we're trying to eliminate kind of these barriers. And in general, also one class per file. Like each class has its own file, and they live by themselves. In class, sometimes I may put in multiple classes in a single file just because I just want all in one screen for you to see. And I'll tell you and I'll remind you like, hey, this is just something I'm doing here, so it's easier for you to see, but one class per file. Any questions about that? I saw a hand pop and disappear. I'm going to presume that when that happens, I've answered the question that you had.
You answered the question.
Cool. Cool. And I'm going to save this. And what I'm going to do is that I'm going to make a runner file. And I am going to open it to the side. Right. And what I'm going to do is that in my runner file, I'm going to tell it that you need to know about the unicorn file. Because if I'm going to run this runner file, I want to be able to instantiate a unicorn object, and it needs to know about it. And we're just going to make unicorns real quick. Unicorn underscore. Nope, that is not the underscore button. One equals new. Well, Alex, you have a question.
Yeah, I remember my first attempt at mod 1 being like
Uh-huh.
confused about like what the runner file was and like
Yeah.
that it wasn't anything special or like calling unicorn.
Mhm.
Can you explain that a little bit?
Yeah. So generally in a class file, we do not want to have any code that sits outside the class definition. A class file should just be that. A unicorn file is, I'm sorry, a runner file is just going to be a file that we run that will start up the things that we need. And so here I made a runner file that I'm going to run. It's going to, what it's going to do is what's required does is like, hey, in this same directory, I want you to go look for unicorn.rb. We don't type in the RB because it's going to, Ruby is going to presume that we're looking for a unicorn file that ends in .rb because we're working Ruby. We are going to instantiate 2 unicorn objects, and what here is this is require pry, bind out pry. And again, like we were talking yesterday, pry is a tool that we're going to use, and what it does in this syntax in this instance is that it is going to stop execution whenever it hits this binding out pry, and it's going to open up an interactive session with this state. So this is going to be already run. So what we can do is that we can see, I can type in unicorn1 and see what this unicorn, what is inside, inside this variable. And we see that we have this object. And what this is saying is that inside this unicorn variable that I've created here, we have an instance of a unicorn object. This is just a text representation of that object. This hexadecimal number after it is just where it sits in memory. You're not really going to use this. It's just kind of important. We just need to know that when we see something that looks like this format, it's saying that this variable is holding an object like that. And so we can see that unicorn 2, and I see that it has a unicorn object. And I also want to note that the numbers here are different, denoting that these are 2 separate objects. Very much similar if you go to the car dealership, you see a white Porsche 911 and a second white Porsche 911. Like, yes, they are the same car, but they are different instances of the car, right? They are separate things. Like if I kick the door in one and leave a dent, now one of them has a dent. The other one doesn't have a dent. They are separate. So like we have here with these unicorns, they are both unicorn objects spawned from the same unicorn class, but they are separate instances of that class. Question so far, Natia?
So I hate to say this, but that doesn't make total sense to me.
That's all right.
What about it? If you're running like an actual, like, I don't know, let's say an application backed by a database where the classes and objects and whatever, like stored in tables, and like you don't need to initiate and say like they all are, like, how does this actually work in real world applications? Does this file just run when you like open Excel or you open Outlook, or how does that look?
So what I've done is that we scroll up, I ran Ruby runner.rb, and this file gets run. And the runner RB goes, I'm like, okay, I see this require unicorn, so I'm going to load up this class, and I'm going to instantiate 2 objects, and without this, that's it. You just instantiate, nothing else happens. Like this is an application. It's not really doing much because we haven't told it to do anything yet.
When I like open Excel, for example, does a file like this open?
You are running a file, and it makes other things happen. Yes. Essentially, running Ruby runner.rb is the same thing as double clicking on your Excel icon.
Thank you.
Yep. Well, yeah.
So I was wondering about this like memory ID of where the variable is stored. Is that tied to the variable name or to what the value? Like if we, for example, redefined unicorn1 and re-instantiated it, would it have that same ID, or would
it wouldn't. So I would say that for all intents and purposes, whatever this number is arbitrary. Under the hood, when you are instantiating an object, Ruby under the hood is finding a location in your memory to kind of keep that, to store it. It has its own strategies and techniques for doing that. I don't know exactly the algorithm which it picks that. Like that is like kind of beyond the scope of this and like beyond like the knowledge I need to have. And so it's this idea of abstraction. I let Ruby handle that. Ruby's gonna find Ruby in conjunction with the operating system is going to find a chunk of memory that is not being used that can now store this in, and it will remember like where it is. So like the only real use you're never honestly you're probably never going to use this this number. It's just important to know that like this is going to be a unique number for every object that you instantiate. You're not going to have an object. You're not going to have two different instances of an object share the same like number. Like it is just a way to show uniqueness. But that's a good question.
Can I actually follow up on that?
Yeah.
Real quick. So, and this may not actually matter, but I'm just thinking, I'm like imagining a location where there's all this memory. Like, is that something we need to think about with efficiency? Like if you're constantly redeclaring a variable, is that just like taking up tons of memory and really inefficient?
At some point, yep. We're gonna so let's kind of roll back a little bit. I feel that there's this thing called the Pareto Principle. Are you familiar with it? You can get like 80% of a thing with 20% of the work. It's the last 20% that takes 80%. And we will show you some small techniques that will take like that 20% of the time. They'll get you a lot more efficiency that you can do. We're not going to concentrate too much on efficiency, but we'll talk a little bit later on about like what things we could do to like make things a little better. The thing is, what I like to say is that Ruby gets this bad rap as like being a slower language, and I think that it is fair to say that, but the big picture is that Ruby is optimized for humans. It is meant to be for the humans who are able to read and write Ruby code very, very quickly. And the thing is, one, it's a whole lot cheaper to throw more hardware at a problem, like to buy another server and have that handle like these efficiencies, than it is to hire another developer, right? That's gonna be hard and more expensive. Second of all, like the places where Ruby starts to get really slow are the kind of points where like you are having to deal with if you're kind of like you've built an app that hundreds of thousands plus people are like using, right? And like if you have that many people using your app or whatever, like that's a good problem to have. Like efficiency is going to be the least of your worries. Like your bigger problems, like how do we monetize that so we can start hiring more people to fix it, right? So like it is not a big as problem as people make it out to be, right? If Ruby and Rails is so terrible, why does GitHub use it? Why does Airbnb use it? Why does Netflix use it? Twitter uses it? Like like it still has advantages no one else has. I saw another hand disappeared. Do we want to come back? Question? Nope. Cool. Oh, Susie, you're muted.
I had a question just about using the binding pry line at the end. I found that when I'm running it, when I have it as the last line, Ruby doesn't pick up on it. But if I sandwich it, like I always have to sandwich it between something for it to run. So I didn't know if that was like a tiny tech.
It depends on the context. So like I'd have to see the exact context what happened.
Like I did this exact thing in my terminal on my computer, but it won't run when it's the last line.
Post a screenshot in the code help channel. We'll take a look at it after class.
Okay.
All right. Okay, it's 9:28. Let's take a break. Let's be back at 9:36. No, wait, let me 9:34. 9:34. All right, recording's back on. Can you still hear me, see me, see my screen? All right, so this unicorn's so useful, right? So useful. They can do all the things. They can do nothing. Because we have just defined this class, unicorn, and like it's just there's nothing in here. It doesn't do anything. We've instantiated objects, and at this point, the only thing that we can do is instantiate these objects. And so what we're going to do is that we're going to start adding attributes to these classes. And just for the purpose of this, we're going to see that each of these unicorns, we're going to say each of these unicorns has a name and a color. And what we're going to do is that attributes, when you were working with classes in Ruby, are stored using what are called instance variables. In general, we define these instance variables in a special method called initialize. It's run every single time a new instance of a class is created. So what we're going to do is over here, make sure I spell that right. I will tell you that whenever you type initialize, say it out loud as you type it, because you will miss a letter and you will spend an unreasonable amount of time trying to figure out what you've done wrong. And the problem the entire time was you misspelled initialize. So that is something to be very aware of. And so when we are initializing a new instance of an object, like we've done here with unicorn.new, it's like, hey, are we not calling the new method on this unicorn class? And yes, we are. One thing to kind of know is that new is kind of what's called an alias for initialize. When we call new, we're actually calling initialize. And whenever we instantiate a new instance of a class, the initialize method gets run. So if I were to take this and I were to quit and I run that, what's happening is this initialize method is getting run every single time instantiated, but nothing's happening. So what we can do is that I can do a hello. And if I do unicorn string equals I didn't need to reload it. You see here, it printed out hello twice because the initialize method was run when we did the unicorn.new. Right. And so this method is run once and only once, and that's when we call new. And like that, initialize is just like any other method. We put Ruby code. Instead of this, we could be fun and do a unicorn has been created. Let's see. Wait. Yeah. That looks even. Sure. Right. And we do this again. We can see that 2 unicorns have been created. Questions about initialize and new? Reminder that initialize is run once during the thing upon creation. Sarah?
Could you kind of repeat what you were saying about when you instantiate and what the purpose of initialize is again?
Yep. Initialize is an alias for new, and initialize is a method that gets run every single time we create an object. Always, no exceptions.
And when you said instantiate?
Instantiate.
Instantiate, and that means to create a new class and initialize instance of the class.
When we create a new instance of a class, one of the words we can use is instantiate because we're creating an instance of it. Yep.
Perfect. Thank you.
Like 100%. Like if there are words I'm using like that you're not quite sure what the meaning is, like 100% ask. Personally, I will try to stay away from what's known as jargon as much as possible, but I will try to use the most specific and appropriate technical term as possible. And usually one of the words that we use to describe the process of creating instances of a class from a class is called instantiation. Cool. Good question. All right. So like we've got this we got like this method, which, now is our unicorn any more useful? Like we still have this goal of like having a unicorn have a name and a color. And so what we're going to do is that we are actually going to make it so that we can tell that upon creation, we can give a unicorn a name and a color. I'm going to take this out because this is going to be annoying. And how we do that is that upon creation, we want to tell the unicorn, like, hey, this is going to be your name, this is your color. So what we're going to do is that we're going to make this do that. And we're going to have name parameter color parameter. We're going to do name equals name. Because I am extra, I like to line these up. I like to line equal signs up. I feel it's a lot easier to read that way. Other people have other thoughts on it. And like, well, if you line it up, if anyone has to make any changes, they have to line it up too. I'm like, yeah, I don't care. It's going to be pretty. It's going to be pretty. The idea is that like someone's going to read this and it's going to be easier to read. And I feel it's easier to read things like that. You don't have to do this. This is a me thing. And so what's happening here is that we are making the initialize method take these arguments, these parameters in, and then in this method, we're going to take them and store them into instance variables. Instance variables are designated with the @ symbol in front of it. This is what makes an instance variable, the @ symbol. And so to kind of actually do this, what we're going to do is that we are going to pass a new some information. So the first one's a name. So the first unicorn is going to be called Sparkle. And it's going to be rainbow colored. The second one is going to, we're not going to give it a name. We're going to leave it as a blank string, and we're just going to have the color white. Cool. I'm going to quit out of my process here. I'm going to run it again. Save everything. Yeah, save everything. Cool. And now what I'm going to do is that I'm just going to type in unicorn 1. And we see here that not only do we have that memory location, that object ID here, we also see that inside in the color instance variable, we are storing rainbow. And the name instance variable, we are storing Sparkle. And if I do this for unicorn 2, you could see that the color is white and the name is a blank string because we pass in an empty string. Mark?
Yeah, is just a basic question. Is that like an array, I guess?
It is not an array. We are kind of like this format is just saying we were passing 2 things. And this is, we divide it with the comma. And also you don't have to qualify your question with saying basic question. Like all questions are like totally valid.
Okay. All right, thanks.
Yep. Caleb?
Hey, so I was curious, when you set your parameters under initialize, in the event, say for some reason, I don't want it to have a name, don't even want it to have a blank space as a string, is there a way to put a placeholder in there or no?
You can by using optional arguments. Like you can see it done in your mythical creatures exercises, but I would not recommend doing that. Like it's generally kind of a little more annoying. I would use like what we're going to do is that later on, let me rephrase. In the future, we are going to talk about different solutions that will let you do that more easily. With what we know right now, like don't do it that way.
Thank you.
Let's see what's next. Jermaine.
Just wanted to go back real quick on the runner file, the binding. dot pry. Just wanted clarification of what that does specifically.
Yeah. So the bind.pry, what that does is that when Ruby hits this line, it is going to pause execution and open up an interactive session in the context of where that bind.pry is. It's known as using it in terms of like using a debugger.
So if you put require pry, the action won't follow through.
I'm sorry. You broke up a little
just
bit.
put require pry, yeah, without putting binding.pry, and you put require pry, it won't open because
It won't.
put require pry.
Require pry means like, hey, I want you to load up the pry software on your computer and have that available for use. The binding.pry is what actually triggers the execution, the pausing, right? Most people generally put a require pry up top and then just the binding pry wherever they need to as they're writing code. But also some people just kind of like shortcut the command, like a keyboard shortcut, and they'll just put it there. However you want to use it is however you want to use it. I have no real preference. Yeah. Cool. Noah?
I had just been searching for a quicker way to type require pry, binding pry. There's got to be a way to build in a shortcut to Atom or something that.
Yeah, there is. Some people do that, and I don't know off the top of my head.
Okay, I'll give it a Google.
Yeah,
I just wondered.
Yeah,
You know.
Yeah, and I don't know off the top of my head. I'm a weirdo in the fact that I'm not a huge fan of letting computers autocomplete or macro things. That is a personal thing. A couple of reasons why. One, I just don't trust computers, which is a really weird thing to say as I sit here teaching you how to program. Two, I feel that like the thing is that I'm not always going to be working on my computer. So I don't want to be hamstrung by shortcuts. Like, for example, like what if you are on an interview and you're in a code challenge, like here we're going to use this environment, like, or someone else's computer, like now you don't have any of your shortcuts or anything, so it's you don't want to look like you don't know what you're doing. Right. And so and that's not really like the best reason for it. It is a personal thing. If you would like to use a shortcut to have type out require pry and bind pry, yeah, 100% do that. These are the reasons I don't do it. I am like a curmudgeonly old man and I don't like shortcuts. I'm sorry. I don't have a better reason for that. Cool. Zach?
Real quick, does it matter that the order that it comes out in? Because I noticed it says color first and then name. Does Ruby read bottom to top? Does that matter?
For which one?
Either of the unicorns that you called. So
like in here?
Yeah, when you read left to right.
Doesn't really
No.
Doesn't really matter. Yeah.
Cool.
It just does the thing. Like actually, like I'm not really sure why like color came first when I've done name here first. Doesn't really matter because it's just listing it. Like this is information that is not like the order of it doesn't matter. And so therefore, like I'll just throw it in there. I'm like, oh, it doesn't really care. If order did matter, I would probably store things differently. But that's going to be like a very specific kind of use case that we're not going to see too often.
Awesome. Thank you.
Noah, did you have another question or is that an old hand? Cool. Yeah. So this here is like a real common pattern, right? We want to create a unicorn with two attributes. So we take in two attributes here, right? We gave initialize some arguments and we save these arguments to instance variables within initialize. And you're going to be doing this a lot. But we also want to show you that there are ways to set default values inside your initialize that don't necessarily are something you send in. For example, we could do something like this. Magical powers equals empty array. So now what's happening is that we are whenever we define a new unicorn, we are going to explicitly give it a name and a color, but it's also by default going to set magical powers to be equal to a empty array. And I'm going to do this because I'm that person. And so if I were to quit this and oops, and run it again, we could see here that unicorn has a color, has sparkle, and has a magical powers attribute, which is an empty array. But we've never, we didn't like say empty array here, it's done here. We've kind of set this default value here. Cool. Question so far? Let's do Natia.
So I know somebody already tried to explain this to me. Like, what is the need and necessity of those little @ symbols?
Yep.
And do you have to use them every time you refer to those variables?
The @ symbol makes this an instance variable.
Right.
And we need to use that @ symbol to refer to an instance variable. Things that are attributes that are state of an object must be stored in an instance variable. Did that answer all your questions? I feel there's like another piece.
When you
on my
refer to
list.
it later on, do you have to use it again?
Yes.
Like the @ symbol every
Yes.
time?
Uh-huh.
Never not. Okay.
Never
and
not.
then the little like 2 dot things, you know, oh, that's colon. Yeah.
What 2 dot things?
Colon. Sometimes
Cool.
it's like colon the parameter.
Yep, those are symbols. We're going to talk about that later.
Okay. Thanks.
Yep. Jameson?
I think you touched on it briefly, but I was asking about the attribute accessor or the attribute reader.
Yep, we're going to talk about that literally next.
Cool.
Caleb?
Just really quick, and this may be an odd question, but under initialize, you have name parameter and color parameter, and you do not have magical powers. Did you not include that because you're not really passing anything through it and you've already set its value? Okay, thank you.
Like I did that to demonstrate that we can have parameters that are set up by default that we do not have to, that are done automatically, that we do not pass in, right? This is one of those situations where like, I don't want to have, like, if I want, I'm thinking to myself, like, I want every unicorn to start with no magical powers but default. Like, why do I have to put in a third thing in the new, right? Like I could do that, but that's just like, like having to do that every single time you instantiate every single object. Like, no, like let's not, let's do this here. And then we're saving ourselves the trouble of having to pass out. We generally want to only pass in what we need through new. And so like, let's do like that, right? You don't want to pass in like 10 million things to new. So like if we don't need to pass that through and do the default value here, like let's do that instead, right? Cool. Alex?
Yeah. Oh no, I think I just forgot my question. No.
Do you want me to? Oh, okay.
What is the difference between an instance variable and an attribute?
We store attributes inside instance variables. An attribute is just an attribute is a generic word describing like, hey, like a car is blue, my refrigerator is a whirlpool, right? In like an attribute is kind of a general term. An instance variable is something that we use to store information in. And usually we are using instance variables to store attributes of an object.
So would it be safe to say that all attributes are instance variables, but not all instance variables are attributes? Or does that not matter at all?
I mean, I think it matters in that, you know, words mean things. And
like in practically,
yeah.
Is that going to impact me if I don't have a concrete idea of the difference?
I think in general, it's safe to assume that. But like, I also want to say, like, you're always going to have your edge cases where you got to do something weird.
Yeah.
Right. So like in general, I would say like it is safe to assume that there are going to be cases where that's not going to be the case. And I think that as you get more experience, you'll be able to pick those out.
Okay. And then I think we're probably going to talk about it soon, but what are situations that you don't need the instance variable in the methods? Like,
we're gonna talk about that. Yeah, I think. Yep. Cool. Lawrence.
just for those of us playing along at home, is there an easy way to find out the require path if I have, how to set that up so that runner can actually find my unicorn?
Yeah. So presuming that it's the same directory, the // will work. That's where you have to be running it from. If you're having particular issues if you're having issues in particular, like with your setup, I would say like post a screenshot and the code help. We'll come back to it like after class.
Thank you.
Sid.
What's the purpose of the runner file? Is it to be able to call multiple classes in that file?
Yeah, the runner file is just going to be code like, here, we're going to use it to instantiate classes and kick things off. Like, we generally don't want any code outside the class definition in these class files.
Thank you.
It's just kind of like this little playground I've set up for myself to like interact with things. I think is the best way to describe it. Cool. Dane?
Oops, sorry. So I just wanted to confirm that I understood Caleb's question in that the reason why we're putting magical powers outside of the actual unicorn file is because.
What do you mean by outside of the unicorn file?
I'm sorry, the runner file has the name parameter and the color parameter is over. It's looking at the unicorn file. Is that right? The unicorn. Yeah. So the magical powers, because all unicorns have the same magical powers, you would assume that you're putting it over there instead of putting it in with the actual inside the unicorn 1, unicorn 2. Okay, I just want to confirm.
So the reason why we're doing magical powers like this is like, this is in my mind, the term I want to use is I want to set up a default attribute. I want all unicorns to have a magical powers of empty array, so that we can add, presumably to add magical powers later on. And so all unicorns are going to start with an empty array. And we put that here because otherwise we'd have to send in a third attribute here. And like, if it's all going to be the same for everyone, like this is the idea of pulling, like not repeating ourselves. And that's how we kind of store that here. I think this will be the reason why and how we do that will become more apparent as we get used to this process moving forward. Good questions. Good questions for everyone.
Yeah, thank you.
Great questions for everyone. I do want to note that when you all ask questions, I forget who asks what questions. So don't be offended if I say someone asks this question. But this picture is like, okay, we've got these attributes and you can see that we have them in here, but can we actually do anything with them? Like, no, we can't actually do anything with them, which is kind of pointless. This unicorn class is still pointless because I can't really do anything. It has color and magical powers and a name, but I can't actually access them. I can't actually read out what they are. And so, what I may want to do is that in general, how we want to access information stored in a class is with a method, right? We want to send it messages or call methods on that class. And so what I would love to do is that I would love for each unicorn to be able to tell me its name. So I'm going to do puts unicorn1.name. And I would love it if unicorn, the name method on unicorn would tell me like, hey, what is your name? And I'm, print that out to the screen. And what I'm going to do is I'm going to save it. I'm going to quit out of pry here, and I'm going to run this thing. And it's going to error out. It's going to say undefined method name for unicorn, no method error. I'm getting a no method error because do we see a name method here? No, right? Like it's going to be like, well, how can I use a name method if I have no name method? So what we want to do is that let us make a name method. Def name. And this is like kind of like what I feel is like the cool thing about programming is like if it doesn't exist, don't care, just make it. Right? You have the power. You can do anything you want. And so if I run this again, like, well, I got a blank space, which is progress, right? I don't have an error message anymore because the error message told me like, hey, you don't have a method called name. Like, okay, well, screw you, error message. I'm going to make myself a name method. And so I've done that. But the problem is that name doesn't, what does name return at this point? Jack, what do you think?
Doesn't return anything.
Yeah, it doesn't return anything. That's where we get the blank space. So where am I storing the name? Brant.
I was just thinking about that. Where does it store it?
Where did I store? Where have I stored it?
Well, it's in the instance variable.
Yeah. What's the
Oh, we
in the
just haven't
instance
returned
variable?
it yet.
Yeah. So we do this. And now, cool. It prints out the name. Sparkle. Fantastic. And so what we can do is that we can do this for the other ones. Def, color. And that's going to return color. Def. Powers. Oops. And now I can do color, powers. Now I want to, let me save it over here. And we see here that print sparkle, rainbow. It's not going to show the magical powers. It's an empty array. It's not going to pop up. But we can see here that I now have access to what is stored in my unicorn. And this is these are what are known as getter methods because they go get the information for me. Questions so far about accessing these attributes?
Which ones are referred to as the getter methods? The one on the right of your screen?
Nope, these. I've
the ones to the
defined
left.
these methods, and these are getter methods.
Those are the getter methods. Okay, thank you.
Mhm. So here's the thing. Like this is like we're at 20 lines of code with 3 attributes. What if I had like 5 attributes? What if I had 10 attributes? We can see like this getting a bit long, right? We can see that the more attributes, and the thing is, you're going to have more attributes. That's just the fact of life. Your life is going to be filled with attributes. I think a good example is like, what if we had a class modeling a user at Amazon, right? You got to figure like, well, we got to have a first name, last name, middle name, probably address is probably a thing you're going to store. Like, you can think about all the magical things that Amazon knows about us. And so what Ruby's done is it has given us what's called syntactical sugar, a little bit of magic that we sprinkle in to make our life a little easier. What I'm going to do is that I'm going to do adder reader, and we'll use colons, name, color, magical powers, like this. And I'm going to comment this all out. And I'm going to run it again. And it still works. This adder reader syntax like this is a shortcut to give us these methods. Jermaine?
So would adder reader also be considered a getter method?
Adder reader is like the special syntax that makes the getter methods for us. This adder reader is essentially doing this for us, except without all the typing. And as you can see, I like lining things up because I just feel it's easier to read. I generally like to put things in order that they're in order initialized. I feel that's the easiest way to read. Some people alphabetize them. I think they're psychopaths. Because like, why? Brent?
Yeah, so, and I think this question was kind of touched on earlier, but now that we have adder reader, in the future methods that we create in the class, will we then need to, still have at name as far as whenever we want to reference name, still use the instance variable?
You could use both.
Or does that change? Okay, I think that was kind of, thank you.
You'll be able to use both. I have a preference, but we'll talk about that later. Noah?
There we go. So I see you've got in your adder reader, you've got them kind of stacked vertically. I had always been doing it horizontally. Is it better convention to do it vertically? Does it not matter?
I like vertically because I feel so. I like vertically is at some point it's going to get way too wide and people are going to scroll over. I feel in general we should try to make our code as tall as possible rather than wide, because I think that for human beings it is easier for us to chunk and kind of decipher data more easily when it's narrow and tall rather than wide. I just think that like it's just easier on the eyes to read. I think that we block things off logically that way. And like I also want to stress how important it is like to get your indentation right, because like in addition to like the actual content of code also has a shape, and this shape can help you debug things when things go wrong. So like indentation and how things line up is more important than one would think. Sarah?
Just so I'm understanding the whole purpose of the require pry, binding pry, why do we get rid of it now that we?
Yeah, because I just put this here.
So that's so the puts replace that require pry, binding pry.
I could still. So I replaced it because it's easier for me just to have these puts here and just rerun the file than running the file and then typing in puts unicorn 1.name. You look skeptical.
No, I understand what you're saying, but what's the purpose of putting it there in the first place? We will eventually be putting these puts there, right? Is it just a placeholder until we put the puts?
It was just a way for me to stop execution and play with it a little bit. Because let me put it this way, like before we had attributes, like it was the easiest way to show you like, hey, these are objects. But now that we have attributes and getter methods, it's a little easier for me to just be like, hey, let's put this thing like, hey, look, it's a thing that does a thing.
Yeah, okay, that makes sense. Thank you.
Yeah. Cool. All right, it's 10:07. Let's take another break. See you back at 10:12. All right. We are back. Anyone have any questions that came up while they were hydrating, hopefully? If not, we will continue. All right. So this is great, right? But we can also create other methods that interact with attributes. So this magical powers being an empty array has been something that's kind of like a precursor to what's happening in the big picture. Is that what we want to do is that we can interact with attributes, we can add to them. Like what if we wanted to add magical powers to our unicorn? And so what we can do is that we can make a method here, and we're going to call it add power, and it's going to take in a power as an argument. And what we're going to do is that we're going to take our magical powers and shovel in that power. And the shovel operator is a thing that we use to add an item onto the end of an array. This is the exact same thing as doing magical powers dot push power. These two lines of code are identical. They do the exact same thing. It's just a different syntactically. People generally like the shovel operator because it's very visual. It helps you, like you see, I'm like, yeah, the thing on the right is going into the thing on the left. I got it. Personally, I prefer push. That's just what I do. You can use either. I literally do not care which one you use. but my preference is to push. And so what I'm going to do here is that unicorn 1, oops, we're going to give it a power. What power should I give unicorn 1? Anyone? What magical power shall I give it?
Flight.
Flight. Flick it. Cool. And what I'm going to do is that I'm going to do a puts unicorn 1 dot magical powers. And I want to run, did I save it? Yep. I want to run it and we're going to see what happens. It has the power of flight. I think that let's do this. I'm going to do a puts unicorn 1 dot magical powers. Actually, I want to do this like to kind of demonstrate the thing Sarah was asking about earlier. I'm going to do that require pry. And I think this is a good kind of example of like how one would use pry like while developing code, right? I just want to test this out. I mean, this method, binding.pry. Cool. So I'm going to run it. And I got my pry here. I'm going to check it out. Okay, unicorn. Unicorn 1. Cool. I got those things, magical powers. The thing. Let's see. You see that magical powers is that empty array? I'm like, cool. All right, all right. So we're gonna add that power. Unicorn 1 dot add power. Nope. String flight. Flight. Cool. So I can check now. See, you got added. Yep, it's got that array of flight. And so binary pie is a powerful tool. Like if you don't like, it is a way that we can just like stop execution, put a thing in there, and just like play things. You like binary pie is free, and just like try things out. Like, does this work? Does this work? Does this not work? And like, hey, cool. I see that now. Like, hey, I know that works. Then I can go up here and be like, unicorn _ 1 dot add power. Light. I know that that's going to work, right? And I can also do other things like a test, like you can add other magical powers. Someone give me another magical power.
Happiness beam.
Happiness beam it is. Right? And I can just play with it and be like, hey, cool. My unicorn 1 now has 2 powers. Flight and happiness beam. And just to make sure, I just want to make sure that I'm doing like things are working the way I want them to. If I check unicorn 2, I can see that unicorn 2 does not have any powers, right? I see that these powers I've added to one unicorn, but not the other. I can verify that these are 2 separate objects, separate instances of that unicorn object. Cool. Questions about this? All right, let's give me a second to pull up this. Zach?
Could you use the shovel method in unicorn 1 dot add power? Could you shovel in flight, or does it have to be that syntax?
What do you mean? I'm not. So like you want to do unicorn 1 dot magical powers shovel in like this? Is that what you're talking about?
Yeah, where it says add power. Could you add flight with the shovel method, or does it have to be in the parentheses?
It has to be in the parentheses because we are passing flight as an argument to the add power method. Right. This is where all the work is being done. We are just passing the argument through.
Okay, so shovel only works on the left
directly
side.
on the array. Yep.
Gotcha.
Molly?
Yeah, so sometimes like I see binding.pry get put in the runner file and sometimes in the like class file. And I'm wondering like how you're making the decisions about like kind of where to put it. And like, I'm not totally clear on when you put it in the class file in particular, like what it does. For that, like where you put it.
So I'm putting it, so in this case, I put it in the runner file because like I want it to, I want to make sure that I want to test things after they've all run, right? Like everything's loaded up. Like this is where I want to like stop that, pause the execution, see what's happening. When a person would put it in a class file, is that when you want to see like, hey, is this working as intended? So I'll give you, I think we have a great example of this. Let's say, for example, the add power method wasn't working the way I wanted it to. What I would then do is I would do the require pry binding.pry in here, this, and then we quit here. Oops. And now I've paused execution of my file inside here. I am inside here. And now I can verify things like, okay, well, what's power? Well, power's flight, right? That comes in, that's what I expected. I can check out what's in magical powers, assembly method. So maybe I can try magical powers, shovel in power. And that works, right? Now that's kind of like a difference of, it depends on where you want to kind of pause execution, take a look at things. Cool.
Thanks. Yep.
Yep. Lawrence. You were muted.
Sorry. Sorry. The original question fell out of my head, but secondary one, is it always proper to set your instance variables inside initialize, the ones that don't have that we aren't passing anything, or do you
generally yes?
Okay.
In general, cool. All right. Other questions before we move on? Fantastic. So what we can do is that what we're doing here is that we're passing a flight power into the thing. And what kind of object is flight? Sammy?
It's a string.
It's a string, right? But I also want to demonstrate to you that we can put other things in there as well. So what if we did this? I'm going to make a new file. I'm going to put it over here. Cool. We're going to make a power class using the things we've learned today. It's going to be a class power and I've already messed up. Class power. And then what I do. This is generally the order I do things when I make classes. Def initialize, and it's going to take in name and energy required. Name, energy required equals energy required. Cool. And I'm going to want, after I set those up, I'm going to, okay, I'm going to make these add a readers, add a reader name. Oops. See, this is why I don't like autocomplete, because it never does exactly what I want it to do. Required. Yeah, that looks good. So what I'm going to do is over here, I'm going to require power, right? Because we're going to use this power class in here. And what I'm going to do is that I'm going to do power equals power.new. And I see here that the power is going to take a name and energy required. Flight 10, just like arbitrary, no real reason I'm picking 10. I just want a number there. And what I'm going to do is that we're going to do that. Fire on. Saved, and I'm going to run it here. And I see unicorn 1. Is that power? Not power, but power is that. And now I can see here what we're going to do is that unicorn 1 dot add power, power being the flight. I can see here that unicorn 1 dot magical powers is a array that has a power object inside. And so this is going to be a pattern you see repeatedly. Power objects, holding objects, holding objects, holding objects. It is a variable Russian nesting doll kind of structure where things are inside other things and other things. And who here remembers that super, super fun logic test you took during the interview? Right? Well, I think that one of the reasons why that has been so effective at determining like potential capabilities of programmer is that to have successfully completed that logic test, you had to hold like multiple pieces of information in your head at the same time. And this is kind of similar. You need to like being able to understand that there's a power object inside this array that is inside the unicorn, and being able to remember where you are and how to navigate up and down these kinds of changes, like critical to success, like understanding like where you are and how to get to things. So if I wanted the string flight, I would have to do something like unicorn 1 dot magical powers, right? So that's an array. So to get we can start chaining things, and we can say magical powers dot first, that's going to be a power, and we can get the name flight. Understanding where you are and how to get to information is going to be super, super critical. But you'll get a lot more practice at this. So don't worry about the things. Cool. Any questions about what we've covered here so far in general as a whole? Jermaine.
Yeah, so I just wanted to see if I'm in the right direction here in regards to the files that hold methods versus the runner file, because my notes and kind of the continuation of this seems to me that the more intricate the methods and the more we should break them up into separate files to hold, versus the runner, we can have as many attributes within them. Is that the right direction?
Yeah, so your runner file is essentially the place where you instantiate methods and run things on methods, right? The classes, like I said before, there should just be a place where you define classes and you just have methods defined. You don't really have anything outside the class definition.
And that we shouldn't be holding multiple methods as well. There should only really be one method at a time per class.
No, classes should have as many methods as they need.
Okay.
Yep. And sometimes it's going to be the one. Like, for example, here in Power, we just have initialize, and there, unicorn, we have the add power one. There is a point to it, like a class can have too many methods, but like that is not really the concern at this point. Like you're not going to really encounter that too much. Caleb?
Hey, I'm just trying to break down kind of how you went about this. So in your pry here, you have unicorn underscore 1 dash add power. And then this power in the parameter power, are you just calling on this new instantiated, I guess, variable?
Yeah.
And that's where you're getting.
So this power here, I've defined here.
Hot dog. Thank you so much.
Yep. Yeah, so I'm sending in a power object that I previously instantiated. That's because I have access to this because the binding up prize below it. So this already exists and I now have access to it. If I were to move this up between here, I would not have access to power. Like this is a thing where like where you put the binary prime matters. Mark?
I think this is a sort of a follow-up from Jermaine's question, but is it convention like to have separate classes in different files, or can you have two classes in one file?
In general, actually, no, I'm not going to say in general. Always one class per file. Occasionally, I may, while teaching, I may put a second class in the same file, just make it easier for you to read, but I'll tell you like I'm only doing this to make it easier for you to read.
Okay, thank you.
Mark, no, you're Mark. Noah?
I just wanted some clarification on, I think it was Jermaine's question about all right, so you're defining add power and then you have that variable there. From what you said, it sounded like you need it to exist in the runner file, but
yes.
I've been defining methods like that with a variable well before I put it in a different file. You can have a variable be just about anything in that method and then feed it something when you call the method, right?
Yeah.
Okay.
If I'm understanding your question, yeah, that sounds reasonable.
Okay.
Leah?
This may be the same or similar question, also a follow on to Jermaine's question, but when like we took power out of the unicorn class to make its own class, when would you make the decision that this needs to be a class rather than a method within this existing class?
So we didn't make it, we didn't take kind of like take things out. Previously we were just passing in previously we were passing in just a string. It was just a string called flight. We decided to make it an object. Well, let's put it this way, like the decision to make the object in this case is kind of arbitrary because like I wanted to show you that, hey, we can store objects like this too. But how we back that up is that we decided that a power has two attributes. It has the name of it and the energy required. I would generally think that it is time to move from like one object to like a custom object if like you have multiple attributes about it, right?
Would that be like over making it a hash, for example?
Yeah, that's a yes. Yeah, I think that what a person could have done something similar to this by using a hash. Like instead of having this power object, you have a hash where the key is name and the another key with the energy required, right? But don't do that. The reason why you don't do that is that what makes a class a class? What are the two things that define a class?
It's state and behavior.
State and behavior, right? Hashes can give you that state, but what can't hashes give you?
Behaviors.
Right. So we want to leverage behaviors to help us out in the future. So though I think that if you're familiar with hashes, and like this is a road I went down very, very badly because I thought like, oh, I'm just gonna use hashes. And then it bit me in the ass hard. And I had to go back and change everything because I needed to add behaviors and I couldn't do that. And I'll give you an example of a behavior we could add to power. Energy required. Let's do this. Right now we have a behavior that we've added to this. If we were using a hash, we wouldn't be able to do that. And I guess we could have the catchphrase also be like created on with that. Right. And if this was going to be like a situation where we use that hash, right, we would have to put the code out here. And when we put that in the runner, it's like, okay, like, oh, this is runner's doing a little too much. Like the responsibility of saying the catchphrase should belong to like whatever. Right? It becomes an organization issue. Cool. Caleb?
So if you did not have catchphrase under initialize and just had it set to Shazam, could I do a setter method on that?
You could. We're not going to be talking about setter methods yet. But you could, that is something you could do.
Thank you.
All right. Anything else? All right. So what we're going to do for the next 20 minutes is that we're going to give you some solo practice. I'll post this in your code help channel. I'm going to put you all in breakout rooms. You can work on it on your own, and I'll hang out in, or you can join other breakout rooms if you like. Where's the breakout room button? Have they taken it away from, no, where are you? There we go. I'm going to make a bunch of breakout rooms. You could go to a breakout room if you want. You can leave them if you want. I'll hang out here if you have questions and need help. There you go. You can now go to a breakout room of your choice. Have fun. And I'm going to stop the recording.